Hi guys, this is Vivek here. Welcome back to my channel. Today in this video we are going to talk about the difference between an inverter and a non-inverter AC. So there are a number of topics that I'm going to discuss in this video as it is a very important question. First of all, we will understand the working principle of an AC. We will see briefly how does an AC works. Second, we will see where this inverter is required, like why this difference is there. So before we understand the difference, we need to understand the working of inverter and non-inverter AC and where this inverter is required. So these two things are very much important. And lastly, we will see the advantage and disadvantage of both the types of AC. Let's get started. Now, before I go into inverter and non-inverter AC, first of all, I would like to discuss with you that how does an AC works. So here we will see a very brief idea that how does an AC works. Now, how an AC is different from a cooler. We all know there is a device known as cooler. So in a cooler, what happens? There is a window, okay, and there is a layer of water. That is, this layer contains water. Now what happens? This cooler takes the external air, because you can see that coolers are installed at windows or some gate. Okay, so it takes the external hot air and make it pass through the layer of water. Once the air passes through the layer of water, the air becomes cool and it enters into the room. Okay, so that's how this cooler works. But that's not how an AC works. An AC works entirely on a different principle. An AC takes the heat inside the room. Okay, like let's say this is the window of an AC and this is some grill. Okay, so through this grill the air goes inside, and inside this AC there is a pipe. Okay, there's a pipe figure, something like this, which looks like this, through which a liquid known as coolant or refrigerant flows. Okay, so this refrigerant liquid flows inside this pipe, and what happens when this heated air, when this hot and humid air passes through these pipes, the liquid inside this pipe, that is the coolant or the refrigerant, absorbs all the heat inside the air and makes the air cool. Finally, when the air becomes cool, that is shooted out again in the room. Okay, and at the same time, this liquid, after absorbing the heat, is converted back to gas, and once it is converted into gas, it is taken into a compressor where the gas is compressed back again into liquid. So that's how an AC works. Now we talked about a compressor. How does a compressor works, or how it looks like? So a compressor is nothing but an engine which looks something like this. Let me make it. So it looks something like this. There is a cylinder which I'm drawing here. This one. This is a cylinder. Inside this cylinder there is a piston. Now what happens? This wheel that you are seeing rotates. Okay, as it begins to rotate and this rod is hinged, so what happens? This piston goes forward and backward. This is called reciprocating movement. Due to this reciprocate movement, what happens? If we talked about the refrigerant which is converted into gas, that gas fills up here, and this compressor, this piston compresses it. Okay, because if it moves in this direction, so there is no leakage or something, so this gas is completely compressed and is converted into liquid refrigerant. So that's how a compressor works. Now to drive this compressor, what is required? We require an induction motor. Okay, so it is coupled to an induction motor, and this is where an inverter is required. Now in a normal AC, what happens? Let me draw this. So this is the working principle of the AC. You can see the hot air goes inside like this. You can see the hot air goes inside from here and it passes through these pipes. This is the refrigerant pipe that I was talking about, and once the hot air passes through these pipes, it is converted into cool air and is shoot inside the room. So that's how AC works. You can learn more about the working principle of an AC. I'll provide the link in the description down below. Now we just saw that to drive a compressor, an induction motor is required. Now in a normal AC, what happens? If you understand in the terms of a control system, so here is our control system. There is a comparator. Okay, a comparator is a device, as we all know, which compares between two or more values and sends an output. So with the help of a remote, we set a reference point. Okay, and there is then our room temperature. Now let's say the room temperature is 25 degrees Celsius and the reference that we are setting up here is 20 degrees Celsius. Now, so there is a temperature difference of 5 degrees Celsius, so the comparator will send a high output. That's how a comparator works. If there is a difference between two inputs that are provided to the comparator, it sends a high output, and if it is not there, it sends a low output. Now, this high output is sent in a form of electric signal. Okay, this temperature is sent as an electric signal which is fed to the control circuit or the driving circuit of a compressor. Okay, so let's say this is the control circuit. CC, I'm writing, this is the control circuit of the compressor. So it is directly fed into the control circuit of the compressor. Now what happens here is that in a non-inverter AC, this comparator output is fed to the compressor input. Now as soon as there a difference of temperature seen by the compressor circuit, okay, like in this case there's a difference of 5 degrees Celsius, so what it will do, it will turn on the compressor. Now turning on of the compressor means turning off of an induction motor. Okay, so an induction motor, as you all know, that an induction motor is a device which works like a short-circuited transformer during start. Okay, so during start the sleep of an induction motor is 1, and we all know that an induction motor during start behaves like a short-circuited transformer, and hence it tries to drag a huge amount of current from the line. So in this case, as there is a difference of 5 degrees Celsius, even if there is a 1 degree Celsius temperature difference, this circuit will cause the compressor to turn on, and if the compressor turns on, that means the induction motor will draw a huge amount of current. Ideally it is around 5 to 6 amps of current. Okay, this is a huge amount of current because the induction motor is starting from 0 speed. So this huge amount of current causes a voltage dip, as well as it also is reflected in our electricity bill, monthly electricity bill, and it is also not good for our environment, because we all know the coal and all these things that are burned for generating this amount of electricity, and this electricity is just being wasted for what? Just turning on the induction motor. This was what the basis of the invention of a inverter AC. In an inverter AC, what happens? We have the same control circuit. Okay, so we have the room temperature input that is taken by a sensor, and there is the reference that we set with the help of our remote. Okay, so the compressor now sends a high output. Now this high output, instead of directly going into the compressor, it passes through a device known as inverter. It passes through inverter. Now where does this goes into the inverter? This output is in the form of electric signal, and in a compressor what happens, for different temperature there is a different output. Like let's say if I grade this comparator like this, like for 5 degrees Celsius temperature difference, if it says a 5 degrees Celsius temperature difference, that means it will send 5 milliamps of output. If there is a 4 degrees Celsius temperature difference, it will, let's say, send 3 milliamps of output. Okay, so it is set like this. Okay, so higher the temperature, higher will be this current, and lower the temperature, lower will be the current that will be sent by the comparator output. Now this output that is being sent by the comparator is fed to a control circuit of the inverter. Instead of control circuit of the compressor, it is sent to the control circuit of the inverter. Now what does this control circuit does? This control circuit helps in firing the inverter IGBTs. We all know that inverters have these switches. Generally it is made like this. Okay, so these switches need to be turned on and turned off at different instant of time. So this control circuit, what it does, it takes this current from the comparator that is coming as an error signal. We call it an error signal instead of current. So this error signal is processed by the control circuit, and based on that error, it drives the gate terminal of the IGBT. Okay, this control circuit is also known as gate driving circuit. Okay, more specifically we call it a gate driving circuit. So it sees that what is the input that is coming from the comparator, and based on that it drives the IGBT. Now if the current is high, that means that the temperature difference is high. So if the current that is coming from the comparator, if the error is high, that means the temperature difference is high. Now if this temperature difference is high, so what will happen? The control circuit will fire the IGBT at a higher frequency. Now due to this higher frequency, we all know if we can control the firing angle of an IGBT inside an inverter, then we get the higher average output. Okay, so the higher the frequency, the higher the average output. So if the temperature difference is high, the control circuit will trigger the IGBT at a very high frequency, and the higher the frequency, that means the higher will be the voltage. Now where this voltage is going, that is an important question. This voltage is fed to the compressor input. Okay, that is directly from the directly from the inverter, it is fed to the compressor input. Okay, or the compressor control circuit. So this is how the inverter AC works. As you can see that initially what we were doing, we were just seeing that if there is a temperature difference, yes or no. Based on that, there was just a binary selection, that is either the compressor will run or it will not run. Okay, but now what is happening? We are saying that what is the actual amount of temperature difference, and based on the difference of the temperature, we are driving the induction motor of the compressor. Now if you can see that if there is a 1 milliamps of output from the compressor, that means the output is obviously low from the comparator. That means the control circuit will trigger the IGBT at a slower frequency, and hence there will be a low average voltage that is applied at the compressor input. So there is a, if the room temperature and the reference temperature is same, then what will happen? The comparator will send no high output, and because of that, what will happen in a non-inverter AC, that it will turn off the compressor. Now, as the compressor will turn off, what will happen? If the temperature again rises back, it will again sense it and it will again drive the compressor starting from 0 speed. That means again there will be a huge amount of current loss. But in case of inverter AC, what happens? Even if the output from the comparator is 0, the inverter keeps on driving the compression induction motor at certain speed. Okay, at a very low speed. So the compressor keeps on rotating at a very low speed, and whenever the speed is required to be raised, what happens? The speed rises up, but it does not attract that much amount of current as like a non-inverter AC, where the current reaches 5 to 6 ampere. Here it reaches somewhere between 2 to 4 amperes, okay, or 2 to 3 amperes, something like that. So there is almost 50% reduction in the current that is taken by the induction motor. And because this current is doing nothing but just starting the induction motor in a non-inverter AC. So in an inverter AC, what happens? This current is taken only once. Okay, like a huge amount of current is taken only once by the induction motor of the compressor. That is only during the start. And in between, even if there is same temperature, or even the temperature difference between the reference and the room temperature is 0, what happens? The compressor keeps on rotating at a certain speed, and in that way, what happens? The average power consumption by the AC is low. Okay, so it helps in saving money as well as environment as well as electricity. So it's a efficient technology. Okay, now this is what we talked about, the advantages of an inverter AC. Now what are the disadvantages? First thing is obviously cost. Cost of a non-inverter AC is lower than that of an inverter AC. Okay, till now, because the technology is relatively new. Another thing is maintenance. The maintenance of a inverter AC is complex compared to that of a non-inverter AC. And also the spare parts are available in abundance of a non-inverter AC, because those are old and we are using it since a long time. Whereas a inverter AC, the maintenance is not that easy, as well as the spare parts are not available readily into the market. So I hope in this video I discussed all the important points regarding the inverter and non-inverter AC. We also saw how does an AC works. And as I said, if you want to know more about how does an AC works, then I will provide a link in the description down below, where you will be able to study how does an AC works. And yeah, that's all for today. Thanks for watching. And do not forget to subscribe to our channel if you haven't already. Share this video, press the like button, and share your feedback or suggestion or query if anything is there in the comment section below. This is Vivek Choubey signing off. Thank you.